The final discussion in lectures will be text analytics. Up to this time, we've talked about all the concepts of data warehousing, business intelligence, data mining. Now we're going to go into the field of text analytics. One of the things we're trying to learn here is what's the difference between data mining, as we described earlier, and text mining, or text analytics, it's better known as. Text mining and why there's a need for it. You want to be able to differentiate between text mining, web mining, and data mining. And you need to understand the different applications for each of these areas. To do this, we're going to review a little bit of what data mining does. Data mining uses data to predict information. It groups it together. We talked about the cluster analysis that it does. We talk about the association that it does as well, and also its ability to find outliers and pattern matching to help us find fraudulent behavior or other type things. So that's what data mining does. What data mining does not do is it's not a blind application of modeling algorithms. It's not brute force number crunching, and it's not some kind of black box magic technology that just automatically will give us the correct answer. We've talked about that before, but those are things that data mining are not. Data mining, however, is normally attacking structured information, and by structured information we mean information that has been cleansed, getting data out of it. A lot of times the data has been transformed, and as we've talked about earlier in this semester, we then take that data and we structure it into a star schema, perhaps a snowflake schema, or even an online analytical cube using cubing, so we can do number slicing and dicing. Those are the things that data mining is really good at and can attack very well. So now when we looked at the difference between data mining and text analytics, we're using here as reference the IBM Watson not a supercomputer, the computer platform that was created for just things, is that on the structured side is where we look at data mining. High degree of organization, usually in a relational database like SQL Server, Oracle, DB2. Unstructured data, on the other hand, that's not as much organization. It can be data in documents. And the example here you see on the spreadsheet is a patient comes in, talks about chest pain, they talks about they smoke, heart history in the family, and then has similar. Those things would not normally fit into a relational table easily, but that's the unstructured data that the text mining / text analytics is good at handling. Again, the spreadsheet data, you're going to look at the variables, the columns, the headings, the rows, sample size, all those type of things are things we're going to look at. We're going to take numerical information, we're going to categorize it, and then we're going to take that text and we're going to dig into that to see what information we can glean from that information, from that data. Data mining almost always looks at the structured data. So think of it as a spreadsheet type of things in rows and columns and in cells. Where text mining looks at documents themselves. So think of it more almost like a spreadsheet versus a Word document or PDFs or any kind of documents that they're semi-structured in the fact that they do have a format, but there is no row column kind of format that describes its schema like it does in a spreadsheet or a relational database. Both data mining and text mining use similar methods. We've talked about the ones in data mining already, and we'll talk a little bit the same here. They've both been very successful without having a specific thing to do it, like the concepts of grammar or the meaning of words. Is when we talked about Watson a few minutes ago, one of the things they're so far in advance with Watson and IBM was for that ability to understand human speech and how it then translate that. And obviously today we all live it with Siri and Alexa and our different worlds of doing those things. And one of the things that text mining does, it takes that text and it transforms it into a numerical data and then does its mathematics on that the numeric data instead of the text data. That's how text mining does the science behind the text analytics. When we're looking at missing values in a data mining thing, that can be a big thing because we don't know if that's a null value, a lack of information, or whatever. It causes us to have questions about the validity or the quality of the data. On the contrary, in text analytics, that's not an issue. We only take what's there. We don't, because there is no schema, there is no this stuff is required. It doesn't cause text mining or text analytics to have a problem. Again, the types of problems are solved very similar. Two of the big ones we talked about in data mining are the same ones we'll talk in text analytics. It's classification and then also to prediction in a linear and nonlinear fashion to be able to get that information out. So those are both items that are done by both data mining as well as text analytics. So when you talk about text mining, recognize that about 80 to 90% of all the corporate data is in some kind of unstructured form or semi-structured form. So it's not, the data is not necessarily in databases or data repositories or even in big data HDF file structures. It's in corporate data somewhere in this vast array of documents that are spread throughout the organization. Tapping that information is a absolute requirement anymore. It used to be just a few years ago, what a great luxury. But now with the onset of what Google has done, what Yahoo has done, what Amazon does every day, it is now table stakes to playing the game. So text mining or text analytics is a semi-automated process to extract knowledge, as we mentioned before, just like in data mining. You're extracting knowledge from unstructured or semi-structured data sources. Text data mining or knowledge discovery in a textual database. That's what we're talking about when we talk about text mining / text analytics. Here's a very nice visualization of how text analytics and text mining fits into the overall BI infrastructure. We've talked about data mining. We've already talked about information extraction, getting data out of source systems and how to get information out there. We haven't spent as much time talking about web mining, but it's very similar in the fact that we're just pulling from the web sources to get it. As you can see, the baseline of all that is the things that are really more what I would call the BI nature versus the science nature is that natural language processing, machine learning, and then we get down to back into the science level of the artificial intelligence and those type of things. So this is a nice visual that gives you an idea of how text mining fits into the overall picture of text analytics. And again, we go back to those comparisons. This is kind of a summary of what we just talked about. Both of them are looking for novel and useful patterns, things that are, remember, human understandable, human relatable. They have automated or semi-automated processes, so there's always some kind of gray matter usually involved, but we try to automate that. And the reason we automate that is because of the pure volume of data. The difference between the two is the nature of the data. Again, structured versus unstructured, meaning one being in a database, one being in files or in documents or even pictures. First, text mining is you have to give it a structure. You basically provide the schema, you make that happen, and then you're able to mine for the data. So that's the extra thing that text mining does, is it actually gives that unstructured data a structure. The benefits are obvious for everyone. Law, academic research, finance, medicine, and some of the things that maybe not be so good. Some of the things that text mining allows to do is like when you turn documents into assignments into turn it in, they're using text mining and text analytics capabilities to determine if they've seen that paper before or how close it is related to other ones, so they get that score of how close that might be to what that would call a borrowed technology. And again, the other one is the electronic communication. We're able to stop a lot of spam from ever getting to people because of using these type of mining and this type of analytics to stop the stuff from coming out. It also helps you prioritize and categorize your mail. It gives you that automatic response where you can have different responses to different people, the rules that you set up, all based on text mining concepts. And again, some of the different areas we've talked about this, pulling data out of documents that are otherwise hard to pull from. You can go topics so that, and we'll talk about that a little bit more when we get into NIME after this, but pulling data out and showing you what are the key concepts or the big concepts. You summarize it, you categorize that data, And then we're using the other terms we're using data mining, the clustering. And then you link those, which is very much like a pattern matching. You link those concepts together and you help answer questions in all kinds of fields. Some of the terminology you'll hear is the unstructured or the semi-structured data, which we talk about, the corpus or the corpa, which talks about the overall subject area, and the different terms, the concepts stemming. So in other words, seeing a word, whether it's close, closed, or closing, all means the same thing or similar things in that word. And then there's things like stop words that you don't want that keeps the subject from going on to others, and you will pull some of those out of your text mining and text analytic processes so that you can see it. We'll talk about synonyms. We'll talk about tokenizing data. These are all terms that you're going to see in the text mining, text analytics field. You're going to see term dictionaries and word frequencies. A big thing that you'll see there is helping find out how often a particular word shows up in a document or a series of documents. You'll talk about parts of speech tagging, otherwise known as POS tagging. You'll have this occurrence, the how often words or subjects show up in documents, so that you have an idea of the level of importance or the level of depth that that particular subject is come in. And then you'll talk about a single value decomposition, otherwise known as latent semantic indexing. These are all things you will see in the text analytics world. And here's a flow at the bottom of this page: is you take the data, you categorize it, as you can see, household versus household, finance versus finance, school versus school, and then from there you move those into the proper folders afterwards so that documents replaced where they needed to be. So when you're getting a new document in, right there, by using this, it's sliding it to where it needs to go so that you're not having to look through this huge amount of data. It's helping you define where that data should be categorized and stored. Here we talk about the information retrieval with a document coming in. It matches the document, it moves out. One of the things I always talk to folks about is when you're submitting online resumes to companies for jobs, they use this all the time. That's why it's so important that if you're going for a job, you try to find the keywords in the application or in the position you're serving and make sure those are part of either your cover letter and or your resume, because those things go through and they're flagged, and those items that hit the keywords get a higher score than those that don't have the exact keywords. So that's one thing you want to look at if you're ever doing a resume, for example. And then you're going to cluster documents, as we mentioned before. You're going to take this document, you're going to organize it, and you're going to categorize, cluster those things into certain areas, group 1 through 5, for example. These are all things that you are allowed to be able to do by getting the text analytics information. And finally, is once you've stored that data, put that data in there, how can you retrieve that information to get the knowledge out of the data analytics and the text analytics that you've done from all of your data? This is the key part, and this is probably the most important part, is that to be able to get that data and get the knowledge out of it once you've done all of your mining. Thank you, and if you have any other questions, feel free to email me or send me IMs, either way you feel most comfortable with.